Okay. So today we'll discuss regarding how to determine slope and deflection for a cantilever beam using unit load method. So in the previous class, we had discussed how to compute the for slope and deflection by using the formula which was derived by using the unit load method. So today we'll do the example numerical on how to determine the slope and deflection as in case of cantilever beam by using the unit load method. So here I have taken a numerical over here wherein we are supposed to determine the slope and deflection for a cantilever beam at the free end. So here A, B, C are the 3 points wherein A is the fixed end and B is the intermediate point that is carrying the load of 20 kilonewton, and C is the free end. C is the free end. Again, C is also carrying the load of 20 kilonewton. So the distance between A to B is 2 meters and that of B to C is 2 meters. So you can also observe over here it is having AB is the span of 2 meters, which is having the moment of inertia of equal to 2I, and BC is having the moment of inertia of equal to I. So here they have also given the value of Young's modulus as 2 into 10 power 5 Newton per mm square and I value as 12 into 10 power 6 mm power 4. So basically, we are supposed to determine what is the slope and deflection at point C, means at the free end. So now, first and foremost step is that as in case of unit load method, so we are supposed to put the point load, we are supposed to assume the point load exactly at the point we are supposed to determine the deflection. So therefore, as in place of point C, we are supposed to put the point load, a point load of magnitude equal to 1 kilonewton. So in order to determine the deflection at point C, means here they have asked exactly at the free end, that is at point C. So exactly at the point where we are supposed to determine the deflection, we are supposed to put the point load of magnitude equal to 1 kilonewton, 1 kilonewton. So and then in order to determine the rotation or slope, in order to determine the rotation or slope, same at the same point at point C itself, we are supposed to put the uh, rotation or the moment of magnitude equal to 1 kilonewton meter. I just repeated. So first beam here, which is I mean, which you can see over here. So it is the beam wherein it is called as real beam. Okay, wherein the load is applied of magnitude equal to 20 and 20 kilonewton. So here in place of in order to find out the deflection, so in place of point C, we are supposed to put the load of magnitude equal to 1 kilonewton. We need to assume a virtual or the imaginary beam in order to determine the deflection. So the deflection they have asked to determine exactly at point C, means at that point itself we are assuming the point load of 1 kilonewton. So therefore I have assumed the point load of 1 kilonewton over here. So similarly, this is for the second case. This is for the deflection, that is delta calculation. So whereas in case of slope or the theta calculation, so we are supposed to assume the unit rotation. Rotation is nothing but the moment. So wherein at the same point in C itself, we are supposed to assume the unit rotation of magnitude equal to 1 in order to compute theta value. So therefore, I have assumed 1 kilonewton load as well as 1 kilonewton moment. Is this clear, all of you? Shall I proceed?
Yes, ma'am.
All of you?
Yes, ma'am.
Okay. So the next thing, the next point, after assuming the deflection, I mean, after assuming the unit load and unit rotation at point C, so we want to compute what is the MP value. MP is the moment due to the real load, moment due to the real load. And mu1 is nothing but the moment due to the moment due to the point load, this one. So this is the point load, which one we have assumed in order to calculate the deflection. So mu2, it is the moment due to the assumed rotation. So this case, third case. So first one is mp, it is the moment due to the real load. Mu1 is the moment due to the applied unit load for calculating the deflection, and mu2 is the applied unit rotation in order to calculate the slope. Okay, so first thing, so since we have two portions in the beam, so one is AB, and one more is BC or CB, whatever it is. So, since we are going to determine the deflection at point C here, so therefore we are going to start from, from C itself. So, therefore, first portion will be CB. So, CB, and second portion is BA. So, we are supposed to take BA also. Why? Because the deflection is due to the integral effect of both 20 kilonewton. It is not only due to one value of 20 kilonewton, because two 20 kilonewton are present. So therefore, we are supposed to take the value of 220 kilonewton also to consider for computing MP value. So now origin for CB will be C here. So again, origin for BA will be B. Origin for BA will be B. So next, the limit of integration, the limit of integration of CB is between. So if you just start from C, at C it is 0, and at B it is 2 meters. So at C it is 0, from 0 to 2, from 0 to 2. So therefore, the limit of integration of portion CB is 0 to 2. So again, so if you are starting from B to A, if you are starting from B to A, B is the starting point. So the limit of integration will be 0 to 2 again, 0 to 2. It is not from C, it is from B we are starting. So therefore, it is 0 to 2. Now, coming on to the calculation of the moment part for the real load. So here you can just see here. So this is C part, this is B part, this is B part. I just assume a section of x, which is at the distance of small x from that of C. Is this diagram visible, all of you? Yes, all of you?
Yes, ma'am.
This is 20 kilonewton, which is present. So for computing the value of MP, I have taken this into consideration. So I have assumed a section of xx, which is at the distance of x from that of C. Now I need to compute what is the moment, due to point load of 20 kilonewton at the distance of x, or at the section xx. So therefore, it will be equal to force into perpendicular distance. So force is 20 kilonewton, distance is x. So it is 20 into x, which is going in the clockwise direction. So as per our sign convention, What is the convention? We are going from right to left. Right to left clockwise means what is that? Convention. It is negative. Correct? All of you. Yes.
Yes,
Ma'am,
ma'am.
can you let some of the students in? They're actually waiting for your permission.
So it is 20 into x, 20 into x. So which is going in, it is going in the clockwise direction. 20 into x, which is going in the clockwise direction. So right hand side, clockwise direction is considered to be as negative. It is considered to be as negative. So it is minus 20 into x. So coming on to the same portion, BC portion, I am going to compute what is MU1 over here. MU1 represents the moment due to unit load, that is second case. So again, this is the BC portion. So this is B, C, and then I again take the section XX. I again take the section XX. So this is the 1 kilonewton load, 1 kilonewton. So this is at the distance of X from that of C point, from that of C point. So now, in order to calculate the moment due to 1 kilonewton at the section of X, so we are going to take the moment as 1 into X, 1 into X, which is in the clockwise direction, 1 into X, which is in the clockwise direction. So right hand side clockwise is considered to be as negative. So it is minus 1 into X will become as minus X, minus X. So next, coming on to the moment due to unit rotation, that is MU2 is the moment due to the unit rotation. So here I have assumed the clockwise rotation. Why I have assumed the clockwise rotation? Why? Because 20 kilonewton is exactly in the downward direction, wherein if I compute the moment of 20 kilonewton at any point, it will be in the clockwise direction. So therefore I have assumed the unit rotation, that is rotation of magnitude equal to 1 kilonewton meter in the clockwise direction itself. So therefore, since the external moment itself is given, so which is in the clockwise direction, so we need to take the direct value of that magnitude in terms of respective sign convention. So it is equal to minus 1. So I value here for CB is equal to I itself. So therefore it will be equal to I. Is this thing clear for portion CB?
Yes, ma'am.
Yes,
All of you?
ma'am.
Or do you want me to repeat once again?
Repeat once again.
Hello? Do you want me to repeat it once again, or is it clear?
Ma'am, repeat once.
Okay. So listen here. So here I have taken a a unit rotation and unit load. Wherein for unit load, I need to compute the deflection delta value, and for unit rotation, I need to compute theta value. So I have two portions here for overall beam. I have two portions here. One is CB and one more is BA. From C, I am computing. So it is from C, it is CB, and from B, it is BA. So wherein if you are going to take from right to left, so for CB, C is the starting point. So it is taken as C as the origin. So from BA, B is the starting point. So I have taken B as the origin point. So next, the limit of the integration value will be from C to B, it is 0 to 2, means 0 at C, and C to B is at the distance of 2 meters. So it is 0 to 2. So from B to A, it is 0 to 2 again, 0 to 2. Consider it as a separate entities. Okay. So it is 0 to 2, 0 to 2. So next, I need to compute the MP value, that is moment due to the real loads. In order to compute the moment due to real loads, I just take the section separately, that is BC part, only the BC part I have considered. So this is the load of 20 kilonewton. So this is the load of 20 kilonewton, and this I just take the section over here, which is EXX at the distance of small x. I just take it as small x from point C. Okay, so now I need to determine what is the moment due to this real load of 20 kilonewton at the distance of x, from C. So therefore, it is nothing but force into perpendicular distance. So force is 20 kilonewton, perpendicular distance is x. So it will be equal to 20 into x. 20 into x, go along the force through the line of action. So it is in the clockwise direction. So we are going from right hand side. So as per our sign convention, I just write the sign convention here, right hand side to left hand side if you are going to calculate. So clockwise moments are considered to be as negative. So anti-clockwise moments are considered to be as positive. So clockwise moments are considered to be as negative and anti-clockwise moments are considered to be as positive. So here we got the value of moment as the clockwise moments. So therefore it is minus 20 into x. So here, in order to calculate the moment due to unit load, that is in the second case, moment due to unit load. So we again take the section only for the BC part or BC or CB part, because only we are doing here. So BC part, again take the section EXX, which is at the distance of small x from C, and this is 1 kilonewton load. So therefore the moment will be equal to 1 into x. Go along the force through the line of action. It is in the clockwise direction. So therefore it will be minus 1 into x, or it will be equal to minus x. Since it is in the clockwise, we have taken it as negative. So coming on to the next one, it is the moment due to the slope or unit rotation. Since the slope of magnitude equal to 1 kilonewton is assumed in the clockwise direction. So why it is assumed in the clockwise direction? Because so exactly at point C, we have the load of 20 kilonewton and in the downward direction. So if we assume that load, if we take the moment due to the 20 kilonewton at any point, it will be in the clockwise direction itself. Because if we are going from right to left, it will be in the clockwise direction itself. So therefore, I have assumed the same direction of the unit magnitude. So therefore, since this the moment itself is given, so direct value has to be taken into consideration as 1 with the negative convention, because it is in the clockwise direction. So again, I value here for CB is equal to I itself. So therefore it is considered to be as I itself. Is this clear for portion CB? All of you?
Yes, ma'am.
Yes, ma'am.
Yes. Shall I proceed?
Yes, ma'am.
Shall I proceed, all of you? Okay, so the next point I have taken into consideration is BA. So for BA, B is the origin point, and then the limit is between 0 to 2. So from B to A, so from 0 to 2 meters, so 2 meters here. So from 0 to 2, because I have taken it as a separate entity. Now, I need to calculate what is the value of BA. So moment due to BA. So you just take the section here. This is B and this is C here. One second. I just tell why I have taken C here, and this is A. So I have the load of equal to 20 here. I have the load of equal to 20 here at point B here, and also I have the load of 20 here at point C. At point C, I have the load of 20 kilonewton. Now, I just take the section over here between A to B, XX, which is at the distance of EX, which is at the distance of EX. So now, why I have taken point C also into consideration, because the load of 20 kilonewton is acting at point C also. Therefore, I'm going to consider the point C also, because the deflection cannot be due to only one entity. And the bending moment calculation, as in case of bending moment calculation, we are not taking the load exactly on that point. We are going to take the load due to the consecutive distances. So since if we just take CB into consideration, previous to point C, we don't have any other point. So we don't have any other point. C is the only starting point. So therefore, I have considered CB itself as a separate entity. But whereas in case of B point, we have the previous point of C, which is previous to that of B, which is carrying the distance of 20 kilonewton. So therefore, the effect of this 20 kilonewton, which is exactly on point C, should also be considered while calculating the moment between AB, because that is also the contributing factor. So therefore, I have considered it. So now, in order to compute the bending moment at section EXX due to the real loads. So this is the distance between BC, it is 2 meters. So I just start from this load, 20 kilonewton. So it is equal to 20 into the distance between C to XX. C to XX section is 2 plus the remaining distance is X. So it is 20 into X plus 2 or 2 plus X, whatever it is. So it is acting in the clockwise direction. So it is considered to be as negative. So the next load is 20 kilonewton. The distance between 20 and XX is nothing but so X distance. So it is equal to 20 into X. 20 into X. So which is in the clockwise again, it is considered to be as negative. So this is the value where I have taken the minus sign into as a common value. Is it clear, all of you? Is this point clear, all of you? Shall I proceed?
Yes, ma'am.
Yes, ma'am.
Shall I proceed, or do you want me to repeat once again?
No, ma'am.
No, ma'am.
Okay. So this is all about for computing MP for the BA part. So coming on to calculation of MU1. MU1 represents the moment due to the unit load applied. So here I again take the section here, A, this is B, and this is C part. So this is C part with the load of magnitude equal to 1 kilonewton. And this is section should be considered between AB itself, which is at the distance of X. So now the load acting here is 1 kilonewton. Why I have considered this load at C? Because we need to calculate deflection at C. So therefore, I have considered the load of 1 at C itself. So therefore, we want to calculate what is the moment due to this 1 kilonewton at the section EX. So therefore, it is 1 into the distance between B to C is 2 meters. So it is 1 into the perpendicular distance is X plus 2. 1 into X plus 2. So which is going in the clockwise direction. Hence, it is considered to be as negative. Is this clear? Is this point clear, all of you?
Yes, ma'am.
So the next thing is moment due to the unit rotation. So moment due to unit rotation is MU2. So again, this unit rotation will remain same throughout the beam. So therefore it should be equal to -1 itself because it is in the clockwise direction. And then I value will be equal to 2i. I value will be equal to 2i for the beam BA. So it is equal to 2i. So this is all about the calculation of calculation table for the deflection and the slope. Is it clear? Shall I proceed?
Ma'am.
So the next thing is we are going to calculate what is the deflection. So we are supposed to calculate what is the deflection here. So first thing is that the deflection formula we have determined by using the unit load method. So that is nothing but mu mp into dx divided by ei is the general formula. Mu mp, product of mu and mp into dx divided by ei. But here mu in particular will be equal to mu1. Why? Because we have taken that for only the deflection. The mu2 is only for the slope. So therefore we need to take it as mu1 into mp into dx divided by ei. Substitute the value of mu1 for cb first. Cb. So mu1 is equal to -20 into x, -20 into x, and then this distance is equal to, this should be equal to -20 into x, and this distance and then mp is equal to -20 into x, and then it is equal to -x. Mu1 is equal to -x dx divided by ei, and then the value of BA. For value of BA, you need to add that, integrate the between the limits 0 to 2. Here mp is equal to -20 into x plus 2 plus 2 20 into x, that one, and then multiply with that of x plus 2 with a negative sign convention into dx divided by 2ei. So this should be equal to 2ei because the value of I is equal to 2i. So therefore it should be equal to 2ei. You please simplify all the things. So you will get the value as 20x square dx divided by ei plus the integration limits 0 to 2i. If I just simplify all these things, I'll get as 40x plus 40 plus 20x. So 20x into x plus 2 divided by 2ei. So again, integration of 20x square. So 20 by ei, I just take it as common. So x square dx integration will be equal to x cube by 3 between the limits 0 to 2, and then I have taken 1 by 2 ei as common over here, and then integration of 40 into 40x square will be equal to x cube by 3, 40x cube by 3, and then 120 x square divided by 2 plus 80x between the limits 0 to 2. So you please integrate that and you will get the same value. Please check with the answer. So at last you will be getting the value of delta as 306.67 divided by EI. 306.67 divided by EI. Have you got the same value, all of you? Please check
Ma'am,
your
shouldn't
answer.
it be 40?
Sorry?
It should be 40x square by 2, no ma'am?
Sorry, 40?
X square by 2.
See here, 40x here is there here. I just multiplied this x here. 40x into x is
Okay.
what? 40x square. Integration of 40x square will be 40x cube divided by 3, right?
Yes, ma'am, got it.
So you just integrate all the things. You'll get the value as 306.67 divided by EI. 306.67 divided by EI. Did you get the same value, all of you? Yes?
Yes, ma'am.
Are you getting the same value, 306.67? Shall I proceed? Shall I proceed?
Yes, ma'am.
All of you?
Yes, ma'am.
Okay. So the next thing is that we are supposed to find out the slope at point C. So slope at point C is nothing but we are going to take the value of theta as mu2 in particular, mu2, because it is the moment due to unit rotation. So it is mu2 multiplied by mp into dx divided by ei. So here mp is 20 into x. So mp is 20 into x. So mu2 you have got it as -1. mu2 you have got it as -1. So minus 20 into x multiplied by -1, it will be plus 20x. So it is equal to plus 20x. So this you need to integrate between the limits 0 to 2, and then this value, the MP value for BA will be equal to 40x plus 40. 40x plus 40. If you just simplify that, you will get 40x by 40 into minus 1. So therefore, you will get the value as plus 40x plus 40 divided by 2ei, because the value of ei here is 2i. So it is 2ei. So if you just simplify all these things, the integration of 20x will be 20 by ei x square by 2. Integration of x is x square by 2. And then I have taken 1 by 2 ei as common over here. 1 by 2 ei as common. So integration of 40x will be 40x square divided by 2, and integration of 40 with reference to dx will be equal to 40x. So all the things you are supposed to put the values of the limits between 0 to 2, and then we'll get the value as 120 divided by ei. 120 divided by ei. So ei value, it is there in the questionnaire itself. You substitute that and simplify, get the value of theta as well as delta in terms of its respective